Okay, today's lecture is going to be on percent composition, specifically for a molecular compound. Okay, now before I start, I want to just ask you a question. Okay, so right here in my hand, I have Smarties, okay? I'm going to put them onto my paper here, and what I want to do, or what I want you to do, is based off of my Smarties that I have here, so let me get them all on here so you can see them. Burp. Okay. Based off of the Smarties here, I want you, right now, so you might have to pause the video, to tell me what the percentage of yellow is from this Smartie package. See if you can figure that out. I'll give you a second. Okay, did you pause it? Did you get 13%? Did you? Okay, let's talk about how you got 13%. Okay, probably what you did is you counted all of the Smarties and you got 15 total. I'm sorry, 15 total. And then probably what you did was you put the 2 yellow over top. Did you not? And then after you did 2 divided by 15, you probably did times 100 to get a percentage. And you probably got somewhere around 13%. If that's what you did, that's exactly right. Okay? Now we'll try this again in class tomorrow just to make sure that you guys are following along here. But what you need to realize is that percent composition is going to be the same for whether I do it with Smarties or whether I do it with a chemical compound. Okay? Percent composition is just part over whole, meaning I can have a part of something over whatever the whole of that something is. And to get the percentage, I'm just going to do 100. And that gives me percent composition. Okay? How much percentage does that thing make up of the entire thing? Okay? So to do this for a chemical formula, all I do is find the mass of the element divided by the molar mass of the compound. So all of the compound times 100, and that gives me percent composition. Okay? So let's try an example here. Let's find the percent composition of carbon inside of CO2. So the first thing I'm going to do is find the molar mass of CO2. So what I'm going to do is 12.01 plus 2 times 16, and that should give me 44.01, and it's grams per 1 mole, okay? So that's going to be the whole, okay? So percent composition for carbon is going to be part carbon divided by whole CO2 times 100. So what I'm going to do is carbon, there's only 1 inside CO2, so I'm going to say 12.01 grams per mole divided by the whole, which was 44.01 grams per mole. Watch units, they both cancel. Times 100 is equal to, so 12.01 divided by 44.01 times 100, the percent composition of carbon with sig figs. Well, I don't have sig figs here, so we'll just say 27.3% carbon. So carbon makes up 27.3% of CO2. Okay, now let's do oxygen. Okay, I'm using the same whole here, 44.01, except this time I have part oxygen over CO2, or whole CO2, I'm sorry. Okay, now it's important to note here, this time my whole has 2 oxygens in it. So for my part, I'm going to say 2 times 16 divided by the 44.01 times 100. So I'm going to do 32 divided by 44.01 times 100, and I should get 72.7% oxygen. Okay, so oxygen makes up 72.7% of CO2. So what do they add up to? Well, these two percentages together should equal 100%. Why? Because I only have carbon and I only have oxygen inside of carbon dioxide. Okay? Let's try another example. Iron 2 phosphate. Look at this. I don't have a formula, so I'm going to have to make one. So I have Fe plus 2 and PO4 negative 3. Charges don't cancel, so I have to crisscross. So the 3 goes down to iron and the 2 goes down to phosphate. So I have Fe3 PO4 2. Okay, this is a little bit bigger here, so let's take a second to do this guy. So I'm going to have iron. So iron weighs 55.85. So I'm going to have, 55.85 times 3 plus phosphorus, which is 30.97 times 2 plus 16 times 8. So this total is 357.49 grams per mole. Okay? All right, so let's do this. Percentage of iron. So I'm doing part iron over whole. Now, it's important to note that I have 3 irons here. Okay? So I'm going to have to do 3 times 55.85 divided by my whole, which is 357.49 times 100. So my percent iron here is divided by 357.49 is 46.9%. Okay, I'm going to do the same thing for phosphorus. So part phosphorus over whole. So I'm going to have 2, because I have 2 phosphoruses, times 30.97 divided by 357.49 times 100. So I'm going to get 17.3%. Okay? And then lastly, my percentage of oxygen is going to be part oxygen over whole. So I'm going to have, I have 8 oxygens. So 8 times 16 divided by 357.49 times 100. So 8 times 16 divided by 357.49, and I get 35.8%. Now my last thing that I can do to check to make sure that this is correct is add them all together to make sure that they equal 100%. So 35.8 plus 17.3 plus 46.9 is 100%. So this question is done correctly. And that's all there is to percent composition, okay? So we'll do some practice in class. Thank you.